Every non-zero vector can be expressed as a product of its magnitude and a unit vector. And the unit vector is essentially providing the direction of that non-zero vector. Let's look at the problem statement first. Find the vector v such that the magnitude of the vector v is equal to 10 and v is in the same direction as 4i minus 6j. We know that to express a vector completely, we need the magnitude and a direction. The magnitude of the vector v is given, but the direction of the vector v is indirectly given, which says v is in the same direction as 4i minus 6j. So we need to find a way to figure out the direction of the vector 4i minus 6j, and that we can use as the direction of the vector v because they indicate the same direction. So how can we find out the direction of the vector 4i minus 6j? We can find out the direction of the vector 4i minus 6j by calculating its unit vector. Because unit vector has length 1, so it doesn't really make any difference except for the fact that we can think of unit vector as providing the direction of that vector. So first things first, we need to calculate the unit vector of this vector 4i minus 6j. But before we get into that, it's important that I remind you some of the key ideas that we'll be using over here. So if v is a vector which has component x and y, then its magnitude can be written as magnitude of the vector v can be written as square root of x squared plus y squared. And we can find out the unit vector then, unit vector, which we can write as v divided by the magnitude of v. So the result of dividing a non-zero vector, v is a non-zero vector, if v is a non-zero vector, the result of dividing a non-zero vector by its magnitude is a unit vector. That's the idea. We're going to be using these ideas right away over here. So what we wanted to do here at first is to calculate the unit vector in the direction of 4i minus 6j. So let's do that. The unit vector in the direction of 4i minus 6j is the vector 4i minus 6j divided by the vector divided by its magnitude. So we're gonna divide this vector by its magnitude, which is this. So this is how we can write down the unit vector. So let's calculate this. 4i minus 6j, and over here we can use this formula to find out the magnitude of the vector. So we can write square root of 4 squared plus minus 6 whole squared. Now that gives us 4i minus 6j divided by square root of 4 squared 16 and negative 6 squared gives you 36, which is going to be equal to 4i minus 6j square root of 52. Great. Now we can write this square root of 52 as 4 times 13. So we can write this as 4 times 13. Now we can factor a 2 from the numerator. Then we can write 2i minus 3j divided by, now if we take out 4, that becomes 2 times square root of 13. Now these 2's cancel each other out. We're going to be left with 2i minus 3j divided by square root of 13. Now we can rationalize the denominator, which is to say that we can multiply and divide by the same term as in the denominator. So we have 13 multiply and divide by the same term. Now what that gives us is 2 times square root of 13i minus 3 times square root of 13j divided by 13. So this is the unit vector in the direction of 4i minus 6j. And the question says that v is in the same direction as 4i minus 6j. What that means is that we can use this unit vector, as we just calculated, as a unit vector of the vector v. Now let me remind you quickly that we can express a vector v as a product of its magnitude and a unit vector. So then we can write a vector v as the magnitude times the unit vector. So this is the unit vector by definition, which we have seen over here, that we have expressed a unit vector as a result of dividing a non-zero vector v by its magnitude. So this is the unit vector and this is the magnitude of the vector. So this is how we can express a vector as a product of its magnitude and the unit vector. Using this idea, we can express our vector v as a product of its magnitude and its unit vector. So we have calculated the unit vector for vector v, which is basically the unit vector of this vector 4i minus 6j. So therefore we can write the vector v with magnitude 10, because it's given in the question that the magnitude of the vector v is 10 in the direction of 4i minus 6j is, so we have v over here and we like to express this v as a magnitude. So the magnitude of v is 10, so I can write 10 times and the unit vector of v. So we have calculated the unit vector in the direction of 4i minus 6j, which is essentially the same direction. So I can write 2 times square root of 13i minus 3 times square root of 13j divided by 13. Now this unit vector is providing us the direction of this non-zero vector v. V is non-zero because it has magnitude 10. And what this magnitude is telling us is that how far the vector is going in that direction. So finally, we can write v as 20 square root of 13 minus 30 times square root of 13j divided by 13. So we have expressed our vector v with the magnitude that was given and the direction of the vector which was indirectly given on this part. That's it. See you in the next lecture.